All right, here we are with section 2.2. We looked at what polynomial functions are. Hopefully you've got an idea of what they are, remembering that the linear, the quadratic, the cubic, the quartic, the quintic, okay? And realizing the patterns that occur with these things, because in order to graph these polynomial functions, you need to know what they look like. They are a family of functions that all work together in the same way. So once you recognize those patterns, it's going to be significantly easier to graph these functions, okay? Now, before we actually move on with this, we got to talk about solutions, roots, zeros, all those things, okay? These all mean the same thing, and what they are where the functions cross the x-axis, okay? They are the x-intercepts. They are solutions to a function. Now, you may remember with your quadratics, you were given functions that looked like this, 7x plus 10, and you were asked to graph them. You were asked to solve them first of all, and when you solved them, you made y equals 0, so you had x squared plus 7x plus 10, and then you were asked to find out what values of x make this true. And what you had to do was factor it. Okay, now hopefully you can see how to factor this. If not, then you need to spend some time factoring. Look at the grade 11 videos that deal with factoring, and they might be able to help you out, okay? So we're looking at pre-calc 11 videos, chapter 5 I think it is. Check out the factoring, deal with quadratics, because once you understand the quadratics, it's much easier to understand the rest of the polynomial functions, okay? X, and you can see hopefully that it's plus 5 and plus 2. Now these are factors, okay? These are factors. Now if you want your solutions or the roots or the zeros, you need to make each of these equal to 0 and then solve them accordingly, which means x would be equal to -5 and x would be equal to -2. And what that means is that it crosses at -2 and it crosses at -5. It's a positive one, which means it opens up, and boom, that would be an approximation of the function graphed, okay? Now when it's equal to 0, you're looking at these points, right? Because this is y equals 0. On the x-axis, y is equal to 0. Similarly, on the y-axis, x is equal to 0, okay? And that's how we find x-intercepts. So there's a lot of things that you have to get here, okay? And you have to understand the difference between the factor versus the solution, okay? Now you might also remember from grade 11 that when you had something like this, what we call a perfect square, if you ended up with a function that looked like this, x squared plus 4x plus 4, when you factor this, or when you find the solution, you make y equals 0. You factor this, you get x plus 2 times x plus 2, which looks like this, x plus 2 all squared. This is what they call multiplicity. Here you have two of the same answers. Your solution, x would be -2, but you have it twice, okay? I don't know if you remember what happened when you had what we call a double root, but hopefully you can be reminded, and hopefully remember from now on, that what happens is a bounce, okay? It bounces, it doesn't actually go through. This idea here is when you have more than one solution that's the same, is called multiplicity, okay? It means that you have more than one of the same solution. Now sometimes you might have 3 of the same solution, or 4 of the same solution, or 5 of the same solution, okay? And what occurs here is, with multiplicity, what occurs is that if you have an even number of the same solution, it bounces, okay? Even number of equal solutions, you bounce off the x-axis, okay? And if you had an odd number of equal solutions, okay, it goes through the x-axis, and this is bounces off x-axis, okay? It bounces off the x-axis. So that, ladies and gentlemen, is what we are going to be doing, is graphing these things, figuring out whether they bounce, whether they go through, what the shape is, where do they start, what's their end behavior, okay? Now, points that you already should know how to find, okay? Points that you should know how to find are the x-intercepts, and that's exactly what I was talking about up here, okay? These are your x-intercepts. When you factor it out, you find your x-intercepts. So you can find them by factoring, okay, if you can. but you can't always do it. What's the other option? You have, for quadratics, you have what we call the quadratic formula, okay? Now, for those of you that remember, you might not need me to write it down, but I will write it down for you, okay? Negative b plus or minus b squared minus 4ac all over 2a. And if you don't know where the a, b, and c come from, then again, I highly suggest you look back at those grade 11 videos and remember how to use the quadratic formula, okay? Often, however, your intercepts would be found by looking at the function. You might have something like this. Y is equal to x squared times x minus 1 times x plus 3. And you'll see that if you want to find the solutions, you make y equals 0. And what I like to do is to break that up because it reminds me that I have two solutions. So in order for this whole thing to be 0, x has to be 0 twice, or 1, or positive 3. And what's going to happen is it crosses here, or it touches or crosses here, it crosses at 1, and it crosses at 3. Now this means it bounces, right? And what degree is this? We talked about degree. Well, if you multiply this all out, you have x to the power of 4. That means, and it's positive, so it comes from up here, it bounces, it goes through, and then goes through. And you've got what we call a quartic equation. Looks like kind of a wonky W, all right? Now, what I'm going to do is I'm going to ask you quickly to see if you can graph these here, okay? It's kind of what I just talked about, and so let's see if we can break it down, right? So first of all, y equals 0, so we have 0 equals x squared, 3 minus x, and x squared plus 1. They threw a tricky one at you here. You can see that this is going to be x times x. This is going to be negative x plus 3, x squared plus 4. We can't really factor that, so we leave it alone. This is a little bit going to mess us up, so you have to do this. You take the negative out, it becomes x minus 3. The negative now makes the whole thing negative. So what we do is we put a negative out front, and then it's x times x minus 3 times x squared plus 4. Since we can't factor that, that's not going to give us a solution, but we can see that my solutions are going to be 0, 0, 3. Okay, so what we do is we put a dot at 0 and we put a dot at 3. What's the degree of this thing? Okay, if you multiplied it out, what would you have? You'd have an x to the power, well, there's 2, 3, 4, 5, so it's an x to the power of 5. That means that it's an odd function, so it starts down at the bottom if it's positive, right? It does 2 loops. Remember we talked about if it's 5, it could have 1, 2, 3, 4 turning points, right? It could have 4 turning points, it could have 3 turning points, it could have a bunch of different turning points. It starts down the bottom if it's positive, but it starts up at the top if it's negative. Since we have a double bounce here, it comes from up top here, it bounces, goes up somewhere, and then comes down, and that's pretty much all we can do right now, okay? It is a negative x squared, so it's a negative x to the power of 5. So the end behavior on this side, it starts at the top, okay? Because originally it starts like this, but now it's starting at the top because it's negative. A lot of things to keep in mind, ladies and gentlemen, all right? Let's try another one. Here we go. So first of all, make it equal to 0. And I'm going to break this down, x plus 1. I'm going to go x plus 1. And I'm going to change this right away, negative to x minus 1, and then x minus 2, which means that the negative goes out front. I got x plus 1, x plus 1, x minus 1, and x minus 2. So my solutions would be negative 1, 1, and 2. It is a degree of, multiplied out, there's 2 x's, another x, that's going to be x to the power of 4. So it's like a quadratic. That's a positive version, right? And this is a negative version. So since it's negative, it's going to start at the bottom. It crosses here at negative 1 and positive 1 and 2. -1 is a bounce. So it starts at the bottom, we bounce, we go through, we come back down, and there we are. That would be an approximation. Well, what else can we find here? We can find the y-intercept too, right? The y-intercept is where x equals 0. So if you put 0 in here, you'd have negative, and that would be 1 and 1. That would be a -1, and that would be a -2. So that's would all equal a -2, which means now it crosses right here at -2 as well. Which reminds me, what I didn't put over here was points you need to know how to find. We also know how to find the y-intercept, because one of the most these are one of the easiest things to do, because the y-intercept, you need to understand that x equals 0. Okay, similarly, just like on the x-intercepts, you got y equals 0. So in any function, all you do is you plug in x equals 0 and you find y. So plug x equals 0 in, find y. Intercept, because that's where your intercept lies. Now, I didn't do it in this first question here because the y-intercept happened to be the x-intercept as well. Here I realized that I could get a better idea of the shape inside because I could find the y-intercept. Let's do one more of these. Okay, let's do one more here. So we can see that I have, if I make this 0, I have x equals 3, I have x equals -2 twice, and I have x equals 1 3 times. X to the power of 1, that's 1, 2, 3, 4, 5, 6. So the degree here is x to the power of 6. Okay, now we are going to graph this bad boy. We've got our numbers here, so 3, okay, -2 twice, and 1 3 times. So remember, that means it goes through, this means it bounces. It's a degree of 6. It's positive. It means it starts up here and ends up here. This is a bounce, so I come down and bounce. Let's find the y-intercept. Oop, I can find the y-intercept. That's where x is equal to 0. So that means I'm going to have -3 times 2 times 2 times 1 times 1 times 1. So 2 times 2 is 4 times 3 is -12. So, well, that didn't work out so well here. Oh, sorry, these are going to be -1s. There you go. So it's going to be a +12, which means it's way up here, kind of. So I go way up, and then it comes back. It goes through because I have 3 of these solutions, and then it goes through that one too because there's one of those solutions. So the y-intercept is +12, right? And then I can't really graph it because my graph's too small, but you get the picture. So that's, ladies and gentlemen, is how we graph polynomial functions, and you will be asked to do a couple other things here as well, okay? So first of all, let's look at this one. How do I find an equation if my solutions are x equals -1, -1, 0, and 2? Now we have to understand the difference between a solution and a factor, okay? So if x is equal to -1, that means x plus 1 is a factor. So now I have y is equal to x plus 1, and I have that twice. I have x equals 0, which means it's just an x, and I have x equals 2, which means it goes to x minus 2 as a factor, x minus 2. All right, you've got it pretty much in the right form here. We can multiply it out, but that becomes a pain in the arse. But what we don't know is the shape, right? So what we always do is we put an a in front here. And then, oops, my apologies. I kicked the chair and I lost you. There you go, I got you back. Now, let's just write down an a here. We'll write x plus 1, there's 2 of them squared. We can put an x in there too, and we can go x minus 2. Now, it says it goes to the 0.15. That means your x is 1 and your y is 5 in this situation. So why don't you put those values in? We'll put the 5 in here. We'll put an a here, and we'll put a 1 in here. 1 plus 1 is 2. 2 squared is 4. Times 1, which is your x, times 1 minus 2 is -1. There you go. So what you now have is 5 equals negative 4a. So a is equal to negative 5/4. So your final answer here would be y equals, I have negative 5/4. Let's put the x in the front, so x and then x plus 1 squared times x minus 2. This is the final equation. And what we can do here is you can use your graphing calculators and you can use your applications to graph these and see what they look like, right? I mean, those are tools that we need to help us figure some of these things out. Let's, well, I'll leave it at that for now. And what I wanted to point out was that sometimes they're not always factorable. So you can use a quadratic formula if you want, or use your app or graphing calculator. Folks, I know it's a lot of stuff. Try the next section, give it a shot. Hopefully we can make some sense out of it.